Hi, everyone. My name is Thomas Roberg, and today I'm going to be speaking to you about 3D printing and how we can use AI to try and control and monitor the 3D printing process. So the reason why I chose this topic is because I'm absolutely passionate about 3D printing, and I love the technology behind it. And it also seemed when we were trying to choose our topics at the start of the year, everything had to have at least something to do with AI in it. So for those who might not know yet, 3D printing, which we call additive manufacturing, is basically a method of creating three-dimensional objects by layering material onto some sort of design bed or model. It basically creates 3D objects by extruding a material on a layer by layer onto a surface. So as you can see here, we have an object that we design, it then gets sliced, then it gets printed layer by layer, and then we have our final object. Okay, cool. So that's great. Now we all have a general idea about what 3D printing is. Why should you actually care about 3D printing? So 3D printing allows us to rapidly prototype new and exciting products, and this allows us to create faster and much more cost-effective designs. This then allows us to further iterate on designs, which really creates a much more efficient process. If you think back in the past, when you wanted to create something, you would have to set up a whole material line or perhaps cast it, and that just took way, way too long. And obviously this accelerates innovation and really reduces the time it takes to get to market. And hopefully that means we can eventually buy our stuff cheaper. But I mean, manufacturing is cool, but let's be honest, none of us here are in manufacturing. So let's talk about something that's a little bit more applicable to the daily person. 3D printing allows you to create your own personalized and customized objects, and these can really be designed to meet your specific needs or preferences. So here are some examples that I have on my desk at home that I've used to print with my 3D printer, and it really can help your desk look more cool and more organized. Another really cool use case for 3D printing is that it can be used to repair and replace your parts in various applications, such as something at home broke, or in major industry in case of a lathe that breaks and you don't want to spend all that money to get a new part. This is particularly useful when you're using something that has no parts that are no longer available, or when you need something really customizable. This really helps to extend the lifespan of products, which will obviously reduce waste and will help save you money. For all you creatives out there, 3D printing has opened, oh, sorry, I went one too far. 3D printing has opened up new possibilities for artists, engineers, as well as designers to really experiment and push boundaries. This allows for you to create really cool and complex forms that would normally be challenging or impossible to produce using traditional methods. Artists can explore these new techniques and materials, allowing for cool new avenues of creativity. An example of this is the super lightweight motorcycle body that was created and then printed, which has the same strength as a typical motorcycle body at a fraction of the cost and weight, allowing you to save money as fuel gets more and more expensive. Lastly, 3D printing has the potential to reduce waste and environmental impact compared to the traditional manufacturing methods. As mentioned previously, 3D printing allows for super optimized designs, which will minimize material usage and energy consumption. Imagine in a factory such as this, where you're producing this part, you're gonna, if you want to cast it, you need to include a chute and a breathing tube, and obviously that's just going to be cut off the part which is in excess. 3D printing allows you to print the part exactly as you specified. Continuing with sustainable development, although I know saving R3 per mold is super cool, perhaps what I think the coolest application of 3D printing is 3D concrete printing. I'm getting a little bit distracted here, only because I think it's super interesting and cool, and it is what I did for my thesis project. But 3D concrete printing is where you can create a concrete structure, such as the one shown, and this is created by extruding concrete from a nozzle which is attached to a robot. For my honors thesis project, I looked at creating a sustainable concrete mix that was locally created, as currently all the mix is imported. Shown in this slide is myself and my supervisor next to the robot that was used to print, and here is the house that was printed, which is on UJ. So now that I've hopefully convinced you why 3D printing is cool and why you should try and care about it, let's talk about how we can use AI to optimize the 3D printing process and how we can create even more cool designs. So in my mind, there are three, maybe four, main areas where we can try and use AI to improve the overall 3D printing process. And these are design optimization, defect analysis, and data analysis. So our first is generative design. As we all know, AI algorithms can really help us optimize certain tasks within our work and within our lives. These applications can range from getting ChatGPT to write all your code for you and impress all the execs on your team, to the creation of a PowerPoint when you start creating your tech talk the day before. Similarly to these things, we can use AI to design and create 3D printed objects. By using generative design techniques, we can use AI to explore a really wide range of design possibilities, which are based on certain constraints and objectives, which will result in a super highly optimized structure that is lightweight and efficient. For all of you who have a printer at home or have used a 3D printer, you know how expensive that material is and that you want your part to be as lightweight as possible. So here we can see where we started with the initial joint, and then using generative technique, we've been able to scale it back to have the same strength as that first joint at 33% of the material cost. On this slide, we have more and more examples of generative design using 3D printing and AI. Each iteration aims to improve upon the previous one. And the way I like to think about it is you usually know it's generative design if it looks super weird. Next, we have defect detection, and these pictures pretty much speak for themselves. For any of you who have used a 3D printer, nothing is more frustrating than getting 2-3 days into a super long print, only for something not to stick properly and then waste all that material. So AI can be used to help monitor in real time in case something might topple or not stick correctly. And if the print does fail, we can use AI algorithms to try and detect that anomaly. And then it will try and work to protect and prevent potential defects and future errors, and then take corrective actions. And these can help ensure high quality parts and reduce wastes. To aid with defect detection, we can then use AI to analyze the large amount of data that we generate during the 3D printing process. This includes sensor data, material properties, and performance metrics. AI can then use algorithms and parse data to extract insights from this data, which AI algorithms can then use to optimize the process as well as identify possible areas for improvement. Additionally, AI can be used to extract large amounts of data to form parameters to create solutions for a specific problem. Now, you might be thinking, in what kind of application do we need something like AI to analyze this much data to create a part? This brings me to my last use of AI in 3D printing: medical applications. We can use all three of these previous reasons I've spoken about to create super efficient and customizable medical implants and prostheses. We can use AI to analyze the super complex parts of the human body and then create a lightweight and efficient prosthesis/implant. AI can help make this process far more efficient, as each person is unique and has their own set of parameters that the print needs to adhere to. Here we can see some examples of some customizable prostheses and implants. So where does that leave us for the future? It's clear that AI as a technology will continue to advance, and thus AI's integration with 3D printing will also continue to advance. I mean, just in the last year, we've seen how much AI can change the way we work. Imagine how much it will change the way we live. I fully expect that AI will lead to further advancements and possibilities within the field of 3D printing. And who knows, maybe in 10 years' time, your next house, car, or even your heart will be 3D printed. Thank you.